Good afternoon and welcome to problem 6.9. I have the free body diagram written up on the left-hand side. There's a couple things, well, not a couple things, but might be a couple things we're going to need to talk about. So point A has smooth pin connections, a reaction in the X direction and the Y direction. There is a roller pin at point C. Notice that it is at a 30-degree angle from the horizon. So we're going to need to figure out what the X and the Y components are for that. So let me, yeah, I can do it in green. So this is a 60-degree angle right here. I know let me get a second color up here just so we can be very clear. If it's a 30-degree angle here, and this makes a 90-degree angle, then this green angle has to be 60. Okay. So I'll draw it over here real quick. There's C. There's our 60-degree angle right here. That makes this C cosine 60 and C sine 60, which we will definitely need in a second. Looking at the overall truss, I'm going to start with forces in the X direction. Looks like we have AX. We have a 10 kip force, and we have C times the cosine of 60. Nothing we can do there. One equation, two unknowns. So summation of forces in the Y direction. We have AY plus C sine 60 equal to 0. Nothing we can do there. What if we take summation of the forces or the moment about at point A? That means AX would not be a player, AY would not be a player, and CX would not be a player. So it only gives us two players. The 10 kip force, let me erase that and redraw it. The 10 kip force is definitely a player. We're probably going to need to figure out what the perpendicular distance is from point B. So we're looking for this distance here from point B to point A, the perpendicular distance between point B and point A. We're going to have to figure that out. We'll come back and do that in a second. And then we have the other force that is prevalent would be CY. So CY is C times sine 60, and the perpendicular distance between point C and point A is 10 feet. If we rotate about point A, the 10 kip force at B is clockwise, which would be negative, and the CY force at C produces a counterclockwise, which is positive. So before we can do the calculation, though, we're missing one value. I've got a couple things, if you notice on the right-hand side, I did a little pre-work. I know that we're probably going to need the angles inside that triangle. I went ahead and also grabbed what the length of the other side was. We need this distance though, and I'm going to call it distance L. We need distance L. Distance L, again, is the perpendicular distance between point B and point A. So if I go over here, kind of all over the place today, but it's going to be okay. This is distance L. This is this 8.6603 foot leg. I got that right here using the Pythagorean theorem. And this is a 60-degree angle. I can get distance L, cosine of 60 degrees is equal to L divided by, oops, there we go, divided by 8.6603 feet. Therefore, L, or distance L, is equal to 4.3302 feet, which is what's going to go right here. 4.3302 feet. And if we do the arithmetic, this is negative 43.302 kip feet. Plus C times the sine of 60 times 10 feet equal to 0. Add 43.302 to both sides. C times the sine of 60 times 10 is equal to 43.302 kip feet. I divide by both sides by sine of 60 times 10. And we get that C is equal to 5 kips. Go ahead and fill that in. I'm going to pause the video right here so that I can get the board set up for our first pen. It occurred to me right after I erased the entire board, or the right-hand side of the board, that we had not gotten all the reactions to our truss. So I've kind of filled in some stuff, and we'll do that now. All right, so we still need AX and AY, summation of forces in the Y direction equal to AY plus 5 times the sine of 60 equal to 0. 5 times the sine of 60 is the Y component of our reaction at point C. That means that AY, therefore AY is equal to negative 5 times the sine of 60. AY is equal to negative 4.33 kips. The negative indicates that I have the AY in the wrong direction. Go ahead and clean that up right now. So it should be going downwards like that. And there we go. Summation of the oops, that's not even close to what I wanted. Summation of the forces in the X direction equal AX plus 10 kips minus 5 times cosine 60, where 5 cosine 60 is the X component of the reaction at point C. If we solve for AX, we get AX is equal to negative 7.5 kip. Negative 7.5 kip indicates that I have the direction incorrect. No problem. Bam. Yeah, let's see, that was 7.5. Oops, I don't want that. AX was 7.5 kip, and AY is 4.33 kips. All right, now we have all the stuff that we need. I'm gonna erase the board real quick, and when we get back, we will definitely be ready. All righty, so I thought we'd start at pin connection A. So there are 4 things going on. There are the 2 reaction forces, 7.5 kip on the X direction, 4.33 kip in the Y direction. We have member AC and member AB. I went ahead and drew our little triangle up here so we can pick up the X and Y components of AB. If we take a look at the summation of the forces in the Y direction, we get negative 4.33 kip plus AB cosine 60 equal to 0. Solving for AB, AB is equal to 4.33 kip divided by cosine 60, which I think gives us 8.66 kips. The positive answer is an indication that I have AB in the correct direction. AB is 8.66 kips. The arrow is pulling away from the pin, which indication that the pin, the member is in tension. Summation of the forces in the X direction, negative 7.5 kip plus AC plus AB sine 60. And we know AB. We recently did an outstanding job calculating that value. Solving for AC in this algebraic equation, we had AC is equal to what? AC is equal to 0 kips. That is interesting. We call that a zero force member. It is neither in compression or tension. It is 0 force. There's no force in AC. I think maybe this week we'll do a video about 0 force members. That is definitely a 0 force member. There's no way that we messed up on the algebra. All right, give me a quick minute to erase this and get set up for our next joint. I'll be right back. All right, we're going to be looking at the pin B. We could have went to pin C. I just didn't want to deal with pin C, to be honest with you. So I'm going to pin B. It's got 3 forces coming off of it, the 8.66 kip force of AB. It's got a 10 kip force externally being applied, and then it has the member BC in it. I've got the triangles for AB up here, so we've got the X and Y component for that one, and the X and Y component for BC. If you're curious to know where the 60-degree angle came from, notice that the 10 kip force and the member AC are parallel. BC is a transverse, alternate interior angles for 60 degrees. So let's see, let's take the summation of the forces in the X direction. But let's do it down here where I've got a little bit more room. I wrote this problem out earlier and it took a little bit more horizontal space than we just had. Summation of the forces in the X direction. So let's see, we've got ABX, which is in the negative direction. We've got 10 kip force in the positive direction. And we've got BCX going in the positive direction. We know what ABX is. It's negative 8.66 cosine 30. We've got the 10 kip force again. And BCX is BC times the cosine of 60, all equal to 0. See, so these two here combine And I have it written down as 10.5 kips plus BC cosine 60 is equal to 0. Solving for BC, we get BC is equal to -5 kips. Oh joy. The negative doesn't mean I'm wrong. It doesn't mean that the force is negative. It just means that I have assumed the wrong direction for the force. So it should actually be going inwards. So 5 kips. And the force going into that pin is an indication that the member is in compression. I want to talk about the zero force member one more time. Hey, AC is at 0 kips. It's a zero force member, probably just there for stability. Maybe if it accepts a load later on, it becomes there's a force, internal force to it. But as it stands right now, it is a 0 kip force or zero force member. Look forward to seeing you guys in the next problem.